This video is going to focus on the human body in space. It will cover some frequently asked questions about aging in space, death in space, and food in space, as well as some interesting things you probably didn't even know about.
Space, you might think you wouldn't be able to eat much variety of foods there, but in reality, there's an endless possibilities of foods they can get up in space. The type of food they have there ranges from coffee, teas, juices. They even have tortillas and waffles. You can even get cereals up there that range from cornflakes like granola or Rice Krispies. The meat they have there, they have a vegetarian option, which was tofu. They also have chicken, beef, and they even have tuna up there. They have applesauces to berries, beef stew to split pea soup. They have a lot of different types of snacks and sweets. They have corn, white to brown rices, green beans to asparagus, yogurt, and even actual oranges. In space, people eat MREs similar to the ones that we have here on Earth. The only difference is the MREs that are designed here for the people on Earth, it's designed to keep an 18 to 22-year-old extremely active soldier ready, while for the MREs that are in space, it's tailored to older and less active adults. The foods with fat have to be carefully decided, since fat can potentially spoil. They can only have non-fat, dried milk, and most of the foods are freezer dried, so no bacteria can grow. Currently in space, the only water they have there is either warm or hot, but they are projected to add another food station that will have a refrigeration station to provide cold drinks to the astronauts in space. On the space station, there's a rehydration station that will rehydrate your MREs in space. In space, you can have a meal replacement drink that comes in either vanilla, strawberry, or chocolate. In space, you're provided 3 meals a day and a snack in between. The station operates on a 10-day meal cycle. Russia provides for half of the food items on board the space station, while the US provides for the other half.
Mark and Scott Kelly were astronaut twins. Scott Kelly was sent to space, but Mark was kept on Earth as a controlled variable. As you get older, your telomerase, which are an important aspect of your DNA, they tend to get shorter. Scott Kelly didn't experience this effect in space while Mark Kelly did on Earth. Scott also received the flu shot in space 3 times, which he reacted positively to, which means if an astronaut was to get sick in space, we would have the means to save him via vaccines or some sort of treatment. Astronauts also lost 1 to 2% of their bone density in space per month. The bones tend to lose density since they don't have to work as hard against gravity to keep you standing upright. Your muscles have the same effect. They also atrophy if you don't constantly work out in space because, they don't have to work as hard. People who need organ replacements get these organs from organ donors. Sometimes the wait to get these organs can be months, even years. People end up dying because they don't get what they need in time. In order to fix this problem, scientists have begun 3D printing organs. One of the problems with that is that on Earth, when the organs are 3D printed, they collapse under their own pressure. But scientists have found that if they 3D print it in space, the microgravity in orbit keeps the organs from collapsing under the usual pressure, and they can be cultivated to be strong enough to withstand gravity on Earth and potentially save somebody's life.
Some people think that you age slower in space, but in reality, it's more complicated than that. In order to understand aging in space, you need to be able to understand space-time. Space-time is a mathematical model that joins space and time into a single idea called a continuum. Also, the strength of any gravitational field slows the passage of time for an object as seen by an observer outside of the field. Space-time can be changed by energy and matter. For example, time on Earth moves slower than it does in space because the gravitational force from Earth bends space-time. This process is called the gravitational time dilation. So, if an astronaut is floating out in space and not near the Earth's gravitational pull, they are aging faster than someone on Earth. The closer you are to Earth's surface, the slower you age. So to put that in perspective, your legs are younger than your shoulders. But the change in the aging is so tiny that it's completely unnoticeable. Now, the faster you are moving, the slower the time moves. This process is called the velocity time dilation. For example, if you stood on Earth and your friend took a rocket to space and flew around the Earth before coming back, you would notice that you aged more than your friend did during their time in space. Therefore, aging in space depends on what you're doing in space. If you were just floating in space, then you would age faster, but if you were moving around the Earth, you would age slower. The reason for this is because the effect of velocity time dilation is greater than the effect of the gravitational dilation. For example, the International Space Station flies around this Earth about 5 miles per second. If you were on the ISS for 6 months, you would age about 0.007 seconds slower than people on Earth.
All of us have seen the movies where an astronaut takes off their helmet or is thrown into space without a helmet and they just explode. Now, while entertaining, this isn't what would really happen. We need to remember that space is a vacuum caused by gravity. And first of all, when we say outer space is a vacuum, we mean that it's empty. We mean that outer space is nearly empty or almost a perfect vacuum. Now, what would happen is the vacuum of space will pull the air out of your body. So if there's air left in your lungs, they would literally just collapse and rupture. Oxygen in the rest of your body will also expand. So you'll balloon up to twice your normal size, but you won't explode. Your skin is elastic enough to hold you together. Any exposed liquid in your body, however, will begin to vaporize. So the surfaces of your tongue, your eyes will boil. Without air in your lungs, blood will stop sending oxygen to your brain and you'll pass out after about 15 seconds. 90 seconds after exposure, you'll die from asphyxiation, and it's also very cold in space and you'll eventually freeze solid. So basically, you wouldn't explode, but all this stuff would happen to you and it'd still be probably equally painful. There's also a conception that if you took your helmet off, you could just hold your breath, and that would prevent you from dying, which is not true because the vacuum is so powerful, it would literally just pull the air right out of you.
Astronauts. Fuck! That was fucking ass.
Brown rice is, green beans to asparagus, and even actual oranges.
They could have broke the lamp.
You would age faster than someone who was just standing still. I just made that up.
Your skin is elastic enough to hold you together.
Go for it.
What the fuck?
Yeah, shit. See, dude, I fucked up.
You're fine.